Students, and welcome back. Today we're going to be talking about the mole. So I put some funny pictures up here for you. If you don't know what this is, it is a mole, the animal. This is also a mole. This lovely gentleman has a mole on his face. A lot of us have moles. And then this is mole, which isn't a mole, but it's spelled the same way and incredibly delicious. So I figured you guys would appreciate that. If you've never had mole, by the way, it's amazing. Please eat it. So, atomic mass, just a little review from stuff that we did way at the beginning of the year, is the mass of an atom relative to the mass of carbon-12. So, it's the mass of an atom when we're comparing it to carbon-12. And carbon-12 is a known mass, so when we look at other atoms, you create atomic mass by comparing it to that atom. Pretty simple. Atomic mass is measured in atomic mass units, also known as AMU. Very simple, again, used to measure atomic mass because atoms are really, really small. So it'd be really hard to use a unit like grams, let's say, because we'd be talking about, billions and trillions of a grams, and something that we really can't measure in that sense. So because atoms are so small, we use a unit called the mole to count them. A mole of an element is equal to the mass on the periodic table. So what I mean by that is if we look at something like carbon, who's got a mass of 12.011 grams, that means that 1 mole of carbon is equal to that mass. So a mole of an element is actually equal to the mass found on the periodic table, the average atomic mass. Very useful for us when we're doing mathematical calculations. A mole is also equal to Avogadro's number. So this lovely genius named Avogadro came up with the idea that a mole of any substance has approximately 6.022 times 10 to the 23rd power particles. If you don't know how many that is, that'd be like moving the decimal point here 23 places this way to the right. That's a very ginormous number. So just as a heads up, it's huge. It's a lot of particles. Why? Because an atom's super small. So you can fit a lot of atoms into a small space. So 12 grams, which is a pretty small amount of carbon, it's about 12 paper clips worth of carbon, has about this many particles in it. That's pretty epic, just so you know. So one thing we're going to learn how to do is calculate the molar mass. The molar mass is the mass of 1 mole of any substance. Now on the periodic table, this is really easy to do because you literally just look at the periodic table. So if you look at any periodic table, including the one that you have on your iPad or one that you have in your notebook, if you look at something like hydrogen has the molar mass of 1. That's its mass on the periodic table. You might want to make a note to yourself that you would find this information on the periodic table. So use the periodic table. And please excuse my writing skills, all right? Use the periodic table. All right. Now that's for individual elements, but let's say we have a compound, something like water, right? So water has multiple elements in it and multiple numbers of elements. So if I want to find the molar mass of a compound, I need to add up the molar masses of all of the elements in that compound. So you see what I did here is I took hydrogen, and since I know there's 2 hydrogens here, I take my mass of hydrogen times 2, so I get 2 grams. For oxygen here, I only have 1 oxygen, so my oxygen is actually just the mass on the table, 15.99 grams. Okay. You can round this to 16. However, usually with molar mass, we tend to round either at the end or not at all. It does affect the accuracy of your calculations. So if you round too early, your molar mass will not be as accurate. So just keep that in mind as you're doing these problems. To find the total mass, I add up my hydrogens. So this is the mass of my H2, right? Plus the mass of my 1 oxygen, and I get 17.99 grams. So that means that 1 mole of water is equal to about 17.99 grams. These calculations are pretty simple. I will show you how to do a couple of them together, and then you guys can figure out the rest of the worksheet on your own. Let's take a look at the worksheet. So I should probably move this over so you guys can actually see it. There we go. All right, so the first part of this worksheet is very simple. If you're finding the molar mass of these, you're going to look on the periodic table. And again, make yourself a note. If you need a note, I'm going to actually type it. All right. Are you going to let me do this? Sweet. No, maybe not. All right. Learning curve. But anyways, look on the periodic table. I cannot stress it enough. Look on the periodic table. Look on the periodic table. So if I did something like Fe, all right, I look on the periodic table. I'm going to write it in blue. All right, so Fe has a molar mass of about 55.85 grams. And please do use grams, all right? Put that unit. It's not 55.85 chickens or 55.85, goobly goops. I don't know, make up something funny. But 55.85 grams, okay? These ones are all single elements. Pretty easy, all right? I'll try one of these down below here. Look at like O2, for example. O2 has 2 oxygens. So we already know that oxygen is 15.99. Again, these numbers are coming from the periodic table. All right? And then since there's 2 oxygens, I'm going to multiply that times 2. Okay? So if I do 15.99 times 2, I get 31.98. Right? So 31.98 grams. And again, don't forget grams, right? There you go. That will be O2. So 1 mole of O2 equals 31.98 grams, since there are 2 oxygens there. Makes sense? Sweet. All right? I'm going to get rid of those. All right, so I can scroll down. Let's do a more challenging one. All right, so one like here, H2SO4. Okay? So I have to add up all of these elements together. So if I look up hydrogen, hydrogen is 1. All right? So H would be 1 times 2. All right? That's 2 grams. All right? Sulfur, if I look sulfur up on the periodic table, it's going to be 32.06. We only have 1 sulfur there. Be careful, you guys. This is where a lot of you guys make mistakes. I do it sometimes too, especially if I rush with these. There's only 1 sulfur here because there's no subscript. All right? And then for oxygen, it's 15.99 times 4. All right? If I do that on the calculator, which will take me, a second since I'm not the fastest in the world, 63.96. Oh, there's my alarm going off. Awesome. All right, I'm going to add these 3 numbers together. So what I'm going to do is I'm going to add up the 3 total masses. All right. So I'm going to add these 3 numbers together. So 2 plus 32.06 plus 63.96. I get 98.02. So my total mass is 98.02 grams. Move this thing out of the way. All right, so again, find the mass of each element individually, and then you add them together to get the total molar mass. I will post an answer key for this worksheet, but not until next week. So your job is to try them out, submit your worksheet, and then when you guys are done, I will post the answer key once your worksheets are turned in, and you can kind of take a look at what you did incorrectly. The one thing I will mention is when you do have parentheses, remember that this number outside the parentheses does apply to both of these. So that means that technically speaking, you have 2 oxygens and 2 hydrogens here, but not 2 calciums. So keep that in mind and have a wonderful rest of the day.